Hi guys, how you guys doing? Welcome back to the stream. Hey John, how are you?
I'm doing great. Simon, how are you doing over there in Orlando?
You know, pretty good. I gotta say, the weather's nice today and got a little bit of flying in and it's a good day.
Nice. You got some flying in. Well, guys, welcome to the stream here at HSC. My name is John Gross. I'm a commercial drone sales advisor for HSC, so I'm here to answer questions on a daily basis about drones, drone technology, spraying drones, all kinds of drones. I have Simon with me today. Simon's my lead tech, as you've already heard. He's over there in Orlando. He got some flying in today. So, Simon, thanks so much for joining us. Thank you, everybody else. What are we doing, man?
Oh man, I'm excited because today we're going to be answering a question that we get, I know you get all the time, which is,
what question is that?
question is, how long will the drone fly? It's sounds like a very simple question, but it has quite a complicated answer to it, I would say.
Well, man, when I first started, I asked you. That's the first question I think I asked you is how long do these things fly?
How long can it fly? Well, frankly, it's a question, like I said, we get all the time. So,
frankly, at the end of the day, you and I both agree it almost doesn't even matter. We can talk about that too.
Yeah, you're right. Yeah, the bottom line is the flight time is not what matters in terms of spraying drones. Sure, other applications, the flight time is critical, but with spraying drones, there are a lot of factors that we're going to talk about that, frankly, make the flight time almost irrelevant, right?
Yeah.
So, we're going to talk about that a little bit, but before we do that, let's introduce ourselves for the people that are coming here for the first time. I know you already introduced yourself, John, but again, I'm Simon. I'm the lead tech here with HSC. I'm always the one answering the kind of the technical questions and doing all the kind of technical brainstorming side of things. So I'm excited to kind of be here today to chat with you about this because it's something that, frankly, it took me a lot of time to understand as well. Is how do we make our operation as efficient as possible? Because that's the bottom line, is what people are interested in knowing by asking how long can it fly is how efficient can I fly? Yeah. I think that's really where it boils down to.
Yeah. And in that flight time, when it comes, how long does it fly, Simon? Let's answer that question real quick.
Well, yeah, sure. We can start with that, right? And the simple answer is, frankly, so we have three main spraying drone platforms. We have the AG-110, the AG-116, and the AG-122. These are three different sizes. And if you want to learn more about that and go into the specs, of course, just go to our website, hsc-uav.com.
Well, it's pretty easy too. Like the 110, the 10 is 10 liters.
10 liters.
16 liters. The 122 is 22 liters. So it's pretty obvious.
Right. Well, what's interesting is all three models actually have a very similar flight time. Right? Mm-hmm. So we're seeing, between the three models, and there's a lot of variables that go into this. I'm just going to give you a kind of a baseline, but we'll see between 12 to 15 minutes of flying time. Mm-hmm. And we'll get into the variables soon. But
okay.
The first question,
and that's for each drone.
Each drone.
Yeah.
Right. So the first question we always get.
But they have different amount of payload.
Right. Well, why would I buy a bigger one if it doesn't fly any longer? Right?
Yeah,
That's
exactly.
the first question we get all the time. Well,
what's the point?
Exactly. So there's quite a few, again, there's a lot of variables that come into play with spraying drones and flight time operations. I think that probably the first and most important is going to be our spray rate. Right? So we have our spray rate.
Well,
then we have our
is a spray rate, because I have to explain that sometimes too.
Sure. So the spray rate, there's a couple different things. So you have our application rate, which is our desired amount per area. Typically, it's going to be in gallons per acre if you're in the U.S.
The desired amount per acre.
Correct. That's going to be our application rate. That's what we want to target. That's our target, right? Then our drone has a limitation in terms of spraying rate, and that's just based on the drone itself. How much can it actually put down and spray?
Wait, that's two variables within the first variable.
Yeah, I know, right? So as you can see, things get pretty complicated here.
I'm sorry.
No, of course. It takes a little bit of time to kind of understand how this works, right?
Well,
and frankly,
that's why we're doing this, folks.
exactly.
I have conversations daily, so I wanted to bring Simon in on a weekly basis to just talk something about spraying drones. So if you have any questions, throw them in the chat, by the way, and we'll just keep on having this conversation. If you're enjoying it, we thank you. But throw us some questions, and we'll try and answer those as well. So keep going, Simon.
Absolutely, and just
one variable. Right now, we're talking about, if you just hopped in, we're talking about battery management and flight time. And the first variable we're discussing is the application rate, which is the desired amount per acre, which is usually like a gallons per acre. It's a target, as Simon just said. But we also have something, like you said, called the spray rate. That's more of the limitation of what the drone can do, and we've got to match those.
Exactly. And that's where the different size drones come into play, because the different size drones carry different amounts of product, and in some cases, depending on the size of the drone, also have different pumps and nozzles and spray systems that affect how much they can put down. Well, so there's more factors into that. So one of them is the amount of gallons per minute that the pumps can put out.
That the pump is capable of.
That the pump is capable of outputting, right? Because the pumps are only capable of outputting a certain amount, right?
That was hard for me because I remember thinking, oh wow, this 10 liter can spray if we put 2 pumps on it this much. But then I learned the other variable of how many nozzles do you have.
Exactly, and the amount of nozzles also affect the swath of the drone. So that also affects the...
And the swath is...
The swath is how wide your spray pattern can be, right? Okay. So a smaller drone is of course going to have a narrower swath compared to the bigger one. It could be a difference of, who knows, 15 feet, right? So that's also going to affect how much area you can cover. So these are some of the main variables. So even though the drone might be able to fly for the same amount of time, the amount of area that you can cover is going to change.
Okay.
Right? A smaller drone is going to cover less area than a larger drone because of a couple, again, the variables that we described. So having less flow rate on the pumps or spray rate, and having a narrower swath, which means we're going to have to do more passes for the same area to cover the same area compared to a larger one. So again, the flight time is really relative compared to the variables that we're introducing into the mix here. It's really interesting to calculate. So,
well, there's a lot goes into it. We've only discussed 2 variables so far.
Right. And we're circling back to the first one that we discussed, which is our application rate. That's really our key variable that determines how much can I spray per flight or per hour or however long you want. Because, again, we have a limitation based on the nozzles and pump of the aircraft. So if we need to apply a very high application rate, for example, the way that we have to control that is by reducing the speed of the aircraft. So by reducing the speed of the aircraft, we're actually, of course, reducing the amount of time that it takes for us to cover an area, or increasing the time, rather. So, oh, John, I think you may have froze there, but we can still hear you just fine.
If you want to turn my camera off, you're more than welcome to, because I don't know what's happening, guys.
Oh, no problem. We'll keep you here for a minute. We'll see if it comes back, but we can still hear you all right. Again, we're still learning. This is a little bit new to us, too. We're experts in the drone world. There you are. You're back. Perfect. No problem.
Sorry about that, guys.
Oh, we're fine. No worries.
So let's get back to where we were. So battery times and flight management. So one of the things in my conversations that I kind of recap at the end of it all is, they all fly about the same amount of time, but one could be holding 10 liters of product, the other could be holding 22 liters of product, and truthfully, 1 gallon an acre, 2 gallons an acre is almost irrelevant, because you're going to use 1 battery per flight, and you almost are going to time out your flights where, okay, I'm going to finish this 2 acres or this 2.5 acres, and I'm going to leave maybe a few liters inside of the drone at the same time. So we really get it down to, and this is what you teach people, Simon, like
exactly.
The training is getting it right down to flight management, battery management, and being and mitigating risk as much as possible.
Exactly.
Because you're still a pilot on these.
Right. I mean, you're still responsible for the aircraft, right?
Yeah. And then to recap, like I tell people, like 10 liters or 22 liters, they're all going to spray in about 8 to 10 minutes. You know, and have enough time to get back safely for you to restart your next mission.
That's right. And another question that we get very often that is related to this is, well, if I only fly for 5 minutes, let's say I only fill my tanks up halfway, and I only fly for 5 minutes, well, can I continue flying on the same battery? And what we always say is no. And there's a couple reasons behind that. First of all, it's a safety issue. The batteries on the aircraft are spec'd out in such a way that they're designed to carry a full payload, so a full tank, when they're fully charged. They're not designed to carry a full payload or full weight when they're not fully charged. So what will happen is if you try to fly the drone with let's say a battery that's at 50% level with a full payload, you're putting an enormous amount of stress on the batteries.
Yeah.
And you could run into an issue where you take off, and in a minute, it triggers our low battery failsafe, which is going to try to bring the drone back to landing. Yeah. The issue there becomes, if you wait too long, or you load the aircraft too much, or the battery's too low, and you try to fly it anyway, the drone might not be able to come back and land safely. So it might enter its critical battery failsafe, which is just going to land it where it's at. It won't be able to come back home. Because unfortunately with drones, they require batteries to stay in the air. It's very, very important. So we can't take any chances.
Important part, for sure.
Right. It's like trying to leave for a road trip with a quarter tank of gas. You know, it's just not going to work.
Well, the other thing that does too, when you stress your batteries out too much, and you and I both know this coming from the RC world, is and especially, I mean, we're in Florida, but you could be anywhere in the world, but your batteries could expand. You know, you could have all kinds of issues. You know, you get 300 cycles or so, and if you stress your batteries too much, you're going to kill the life of your batteries. So we actually err on the side of caution. I mean, even if you only use 30% of your battery, it's going to take, like you told me, exponentially longer to charge a battery that's 60% drained versus 30% drained. So you might as well pop it on the charger and grab a new fresh battery and be good to go and know that your expensive aircraft is going to be safe.
Absolutely, and I'm so glad that you mentioned that. So, like you mentioned, it does take exponentially longer to charge a more discharged battery. So charging, one thing that I think a lot of people don't realize is charging a battery that's not fully depleted is just reducing your charge time. So your overall efficiency in terms of operation is actually increasing by just putting it back on the charger. Because charging a battery that's at 50% might only take 20 minutes versus charging a battery that's completely discharged might take 90 minutes, right? So it's actually costing you more time by trying to use all of the battery up. On top of that, like you just said, it also affects the overall longevity of the battery, especially if you're operating in hot days. Pushing the battery that hard is really going to get it hot. And when it's that hot, you have another issue where you can't charge it when it's too hot. The battery can go into an over temperature failsafe and not even allow you to charge. So this is why we always recommend, basically anytime you take off, you should have a full battery. And that's actually part of our pre-flight checklist too. We've seen what can happen if you don't follow that. It's not pretty.
Yeah. I'm hearing that there's a little bit of an echo with my microphone. So folks, if you're watching, I want to apologize. I'm trying to adjust. I don't know. So Simon, I'm going to back off and let you kind of take this just for a little bit until people let me know if my microphone's
Got it. It sounds okay on my end, but we'll have you guys comment. If you guys keep hearing an echo, we'll make sure to compensate for that next time around. But I might be able to dial you down just a little bit. No, I do not. It's hearing you through my speakers, yeah. I'm going to turn your volume down so it'll prevent that. Yeah, it should be a lot better now. Again, we're still learning our stream. This is just our second episode, guys, so make sure to tune in again for our next episode. We are going to do these every Tuesday at noon Eastern. We'd love for you guys to come in and ask questions. Again, we have a public chat on board here, and we're taking any suggestions for topics that you guys want to learn about. So please, please, please comment for any topics that you want to know about, whether it's spraying drones or anything else related to drones. We'd love to discuss that, and of course, any comments, we'll answer them live. Again, make sure to subscribe because that's how you get your notifications when we start our stream. But again, Tuesdays at noon Eastern. All right, let's talk a little bit about charging batteries. I don't think we've really touched on that. So, charging batteries. We've talked about using batteries, but let's discuss charging batteries a little bit. So, when we charge our batteries, there's a couple factors that we need to take into account. And this is a question that I've heard a lot in my training is, well, what power source can I use to charge my batteries? Because our charger, the chargers that we offer only offer an AC input, right? So it's like a wall socket. And I've heard countless times, well, I can't wait to connect my charger to a inverter in my truck and just charge it off of my truck. And unfortunately, I have to break the news that just simply isn't going to work. There's a lot of energy that these batteries have to consume to be charged. And the chargers that we're using, we're basically putting as much current into the batteries as we can based on our input, which is our wall socket. So most wall sockets and most breakers for your typical socket that you use on your wall is a 15 amp socket. In some cases it might be a 20 amp socket, but essentially that's limiting our power output from that socket to about 1500 watts, in some cases a little bit more, but 1500 is a safe number. So that's essentially the maximum amount of power that we're able to charge our batteries from a typical socket. Essentially, it's going to be really difficult to find an inverter or a power source in a vehicle that is able to provide that type of output for an extended period of time too, because when we're charging our batteries in the field, we're basically charging all day for an all-day operation.
Yeah, we're running all day long.
All day long. So it's just not feasible to do so on a vehicle. You're putting way too much stress on a vehicle. It's just not worth the cost. So our first recommendation is always, if you're in the field and you don't have a power source, use a generator. A generator is the way to go. We always recommend for generators to kind of oversize them slightly because from my experience, the ratings on generators tend to be optimistic. To say the least, especially if you're working in high temperatures on hot days, continuous operations. So for example, for my training classes, I just have a single 1800 watt generator. It's very small, it's portable, you can carry it with one hand. A gallon of gas will run all day long and it's quiet. It doesn't intrude too much. But that generator can only run one charger. So if you do want to run multiple chargers, you either need a larger generator, or my preference is actually to have multiple small generators, because in some cases you may not be running all your chargers at the same time. So by having two small generators, you can pick and choose. You can save a lot of fuel and it's a lot less noise. And I don't think a lot of people consider the noise, but when it's right next to you and you're trying to operate the drone, it's kind of annoying. It's louder than the drone. Yeah, we always try to push it away and just run an extension cord. But
you could do a big generator,
right.
Or, like you said, get two small ones. And I like that idea because on the small one, if you're only doing a small operation that day, you don't burn extra gas running a generator for extra watts. But on your bigger jobs, and we actually have an option, folks. If you want a generator, when you purchase your drone, we can put it on there for you, so that way it just comes and you don't have to think about it.
That's right, exactly. Yeah, and again, there's a couple reasons why I prefer the smaller generators, but like you hit the nail on the head. Basically, you're able to pick and choose if you need to run both or just one. It just gives more flexibility, in my opinion, and you always have a backup. We're all about that. That's right. That's right. So our typical charging time, whether it's from a wall socket or a generator, it doesn't really affect the charging time. On a typical operation, typical flight, we don't discharge our batteries completely. That's to keep a reserve battery on board to make sure that it's safe to fly. So a typical flight, will discharge the battery to about 25% or so. And from that level, it'll take about 45 minutes to 55 minutes or so to charge. That's pretty standard. So the charging time is not that, it's pretty quick actually. And again, most of that is limited by our power input. So, we're working on some things in the background to see if we can speed up the charging a little bit more with some different power inputs, like 240 volt inputs to boost the power input a little bit more. But so stay tuned, guys, because that might be coming. But
well, Simon, in the last
yeah.
10 minutes, I'd like to talk about our packages at HSC, our spraying drones, and
Great.
how they're set up to help you manage your flight times and your battery management, kind of the way they're designed. So we have a base package and then a fly all day package. Because a lot of people ask me, okay, that's great, now I know flight times, now I get it. What do I need to do this?
Right. Great question. So again, like you said, we do offer what we call a fly all day package. That package is going to vary from drone to drone based on the size. But essentially, the fly all day package, as the name implies, includes enough batteries and chargers for you to be able to cycle your batteries and charging to be able to keep the drone essentially in the air nonstop. So again, that package is going to vary based on the size of drone, but we typically recommend, like I believe it's 4 sets of batteries per drone and at least 2 sets of chargers, if I'm not mistaken. John.
That would get you probably like half a day's operation, and it's kind of designed in, if you buy the base package with the 4 sets of batteries, I should say, because the larger drone takes 2 batteries per set.
Right.
It's designed in a way to go out, get your morning spray done, right? You're going to get to a point, all your batteries will be on charge probably. It's going to be near lunchtime, redo chemicals, and then in the afternoon you can get another set of spraying in with those 4 sets of batteries. But if you need to continuously operate 2 spray, you just need to upgrade to 4 more sets of batteries. And so it's basically 8 sets of batteries and 2 or 4 chargers, right? Depending on which drone we're talking about.
That's right, exactly. And if you guys haven't seen it already, I would definitely recommend you guys to check out this video that we have on our YouTube page. You should be able to see it there. This is our drone batteries, charging, and productivity video that we put together a couple weeks ago. This goes into the details and timing and really the math behind actually timing how the batteries charge and operate. It's really, really interesting, and you can see just how much area you can actually cover with the batteries that we recommend. So I highly recommend taking a look at this video. I think it's very clear in how it lays it out in terms of the time frame and how to charge batteries. So if you guys haven't checked it out, go click on our channel and check out this video. It'll go into a lot more detail of how the battery charging and productivity really works.
Yeah, I love that video. I actually have it in my email signature as one of my favorite YouTube videos on our own channel to get people that I'm communicating with to watch it because it is so well done.
That's right. That's right. Yeah, it's really, really helpful. I think Brian, he's of course the president of HSC, did an awesome job on that video. I think it makes it really clear and helpful on how to set that up.
So Simon, I don't see any questions in the chat. If anybody has any questions, feel free to throw it in there. I definitely need a little bit better camera, I'm noticing, because yours looks great.
Hey, I'm trying some new stuff. It seems like it's working pretty well now. Clearly, I need to get some headphones. That's all right. Hey, we're working through it. It's just going to get better and better. And again, I think I said this in the first episode, but we're also using this Lunch and Learn as a kind of a practice run for our flight demos. We're really trying to improve the quality for our flight demos in the future. So just, you guys stay tuned. We've got some really cool trick stuff coming up for that. John, there is something I want to cover since we got a little bit of time left here that, a question that we've heard a lot and a request that we've heard a lot, and that has to do with hybrid systems.
I got that today.
Yeah, right? So when we are discussing a hybrid drone, essentially it's very much like a hybrid vehicle where you would have a electric powertrain, right? So the drone essentially stays the same. You have electric motors lifting it, it's running the rotors, but the power source changes, right? So rather than having a set of batteries, you would have a gasoline engine that runs a generator on board the drone.
Kind of like an alternator in a car.
Kind of like, yeah, like an alternator on a car, right? So, we've done a lot of experimentation with these systems, and we've seen some other systems available out there that some pretty extravagant claims. So this is our experience with it. I'll give my experience. So I think the concept is excellent, right? It really makes a lot of sense because essentially it doesn't require you to have batteries. You just have to fill up the tank, start the engine, and go, right? You're removing the charging aspect from that aircraft. However, in practice, things are a little bit different. From my experience, they've been very different. So there's a couple factors that come into play. So first of all, the aircraft still requires a battery pack on board as a backup. So if you run out of fuel or if the generator fails, the aircraft can still land safely.
That's more weight.
And that's more weight, right? Remember, all this weight is cutting into the payload of the aircraft. So this is all removing your liquid payload away. Right?
Power weight ratio, I think, is kind of what we call it.
Yeah, so the power to weight ratio is tricky because the only way to really make this system work is with a 2-cycle gasoline engine. Because they're very, very light but would have a lot of power. And that's great. Unfortunately, there's a lot of issues with that. If anybody that's use a chainsaw or a weed whacker that's 2-stroke knows about this. First of all, you need mixed fuel, right? You need high octane mixed fuel. Then, more so than that, most carbureted engines, which pretty much all of the hybrid systems out there are, really need non-ethanol mixed fuel. So right now you're narrowing down your choices dramatically, and it just makes it more difficult to operate.
Let's not forget that we're talking about a carburetor. You just mentioned a carburetor.
Exactly. So that's the...
A carburetor on a model airplane. Your dad probably can, but
yeah.
I don't have that skill.
That's right. So changes in altitude are going to affect the tuning, right?
Lean it out,
Changes in temperature are going to affect the tuning.
You have to learn to operate a hybrid, but there's more to it than that, so keep going.
Yeah, there is. And really what it boils down to is reliability. We just didn't see the reliability in hybrid systems. And what we found is, for example, for a 10-liter model, the size of the aircraft is more in line with like a 20-liter model because it has to carry so much more equipment and weight. And the flight time isn't any better because you still have to land in 8 to 10 minutes to reload the liquid tank.
Yeah, I was just going to say, does it really matter because the 10 liters is going to finish spraying depending on the nozzles.
Exactly. So that's the big issue, right? And beyond that, you have all the maintenance now of a gasoline engine. Most of the engines that we tested and worked with required essentially a rebuild every 50 to 60 hours. I mean, that's a lot of maintenance. And the overall cost, including the fuel, the oil, the maintenance, the rebuild, all that stuff, it didn't really add up. And then you take the reliability aspect where you have to have the engine starting and then you have overheating issues on hot days. A simple electric battery is just a lot easier.
Didn't you tell me a story too about just the vibration alone within the engine?
Yes, so then you have all the vibration issues.
Things and like you could literally just the motor could just fall.
Yeah, and there's two more things that I don't like about the hybrid systems. Again, vibrations are a big issue, so there's a lot of design elements that have to be taken into account for vibration. Then you have the noise. These things are incredibly loud. I mean, imagine a 2-stroke dirt bike, full throttle all the time. and lastly, one thing that I really didn't like is they are just messy. You get oil and gasoline everywhere. They always smell. The beauty of the drones is that you just plug in the battery and it always works. It's 100% the same every single time. The consistency is key. And that wasn't there with the hybrid system. So, I'm really hoping in the future we see improvements in the hybrid systems. I do think the concept is really sound. It makes sense. But right now, I don't think the technology is quite there yet.
I agree. Yeah, it would be exciting if it gets there.
I agree.
It's also another gasoline engine flying around that could explode.
Yeah. You're also carrying gasoline on board. Something to consider.
So anyway, Wow, this has been great. We're getting close to the end of our promised 30 minutes for our Lunch and Learn on Tuesday. We'll do this again next week. We'll get those topics out to you as soon as possible. We're going to be doing this weekly, so please hop in, ask questions. And Simon, I'm going to let you close it off since I think I might still have a tad bit of an echo.
Got it, no problem. Yeah, again, guys, thanks for joining us. Again, if you do have any comments or questions, you can ask in the video or just feel free to contact us on our website, www.hse-uav.com. Don't forget to like and subscribe on our YouTube channel. That really helps us push and promote our Lunch and Learns and let people, educate people on spraying drones. So make sure to click on that. That's also going to notify you of any future videos. We do demos and Lunch and Learns.
Simon.
Yes.
YouTube channel real quick for them.
The YouTube channel is HSC-UAV. You'll find it really easily. Yeah, and you'll find it right below here. Just click on that subscribe button. And again, that's how you'll get notified of any new videos. We do in-person and virtual flight demos every month. We'll do Lunch and Learns every week, and we're adding videos more and more frequently, so make sure to check back here. And I think we'll go ahead and close it out there. John, anything else you want to say?
No, I just want to apologize for telling you to go there because we're actually on YouTube, guys. I'm still getting used to it because I'm neutral, right?
You're right.
Put it on YouTube, but we're on YouTube. Thank you guys for watching. We'll see you next week.
All right. Bye, guys.